Okay, so we're going to go through some questions from Unit 9, Worksheet 3. I'm going to start with 22 because that one had more questions than the other problems. So 22 is log base 10, well, let's back up, log of 1 over the square root of 1,000. Okay, so some of you are getting the negative 3 part, but not getting the denominator. So first of all, let's change this to an exponential equation. So this would be 10 to what power equals 1 over the square root of 1,000. And I know the base is 10 because if it's not written on a logarithm, then it's base 10. If it's not written on a natural log, it's base e, but this is not a natural log. So on the left, right here, I have a base of 10, and over here I have 1,000. So I'm going to change that 1,000. It's also in the denominator, so eventually we're going to move it to the numerator as well. So starting with keeping the 10 to the x the same, I'm going to rewrite this as 1 over the square root of, and 1,000 I'm going to write as 10 to the proper power. So since there's 3 zeros, this would be 10 to the third power. All right. Now your answers need to all be written in exponential form. So I'm going to change the radical to an exponent. So when you change a radical to an exponent, the exponent, which is right here, this exponent, is the numerator, and your index is the denominator. So if it's not written right there, we know that there's an invisible 2 as our index. So this would actually be 10 to the 3 over 2. And then our very last step is to make sure that this is in the numerator instead of the denominator. Let's do that in a different color, numerator instead of the denominator. And whenever you try to move a base across the fraction line, then you change the exponent to the opposite. So that would be a negative 3 over 2 instead of a positive 3 over 2, which means our exponent is negative 3 over 2. All right. Number 12 is our next problem. So on number 12, going back up, we have (49) to the x minus 2 equals 7 root 7. Okay, so a couple things. We need to change the 49 to a base of 7. So 49 is 7 squared. This 49 right here, 7 squared. And then I have this x minus 2 on the outside. On the right-hand side, I know I want everything in exponential form, so that 7 is going to stay the same, but this 7 is going to be 7 to the 1/2. Because of the square root. So the square root just changes. I have an exponent of 1 and an index of 2, so that's why we do to the 1/2 power. All right, now on the left-hand side here, whenever you have 2 exponents, so a power to a power, that's the power rule for exponents. So you're actually going to multiply those exponents together. So this would be 7. If you're going to multiply 2 times x minus 2, you need to make sure you distribute. So that would be 7 to the 2x minus 2. You can leave it as 7 times 2x. Oh, that's not right. 2x minus 4. Sorry. Distribute. So you can leave it in this form until the very end, but eventually we're going to have to distribute. And then on the right-hand side, this is 7 to the first power times 7 to the 1/2. So this is not the power rule. Over on the left side, we did a power to a power, so we multiplied. If you have a base to a power times the same base to a power, you have to add. So we're going to add those exponents, which would be 7 to the 1 1/2. Now we never use the mixed numbers, so I'm going to rewrite that as 7 to the 3/2. If you don't remember how to change a mixed number to an improper fraction, remember you're going to do 2 times 1, and then, which is 2, and then plus 1, which gives you 3, so this is 3/2. Or you would just go ahead and say, well, the 1 is 1 whole, so 2/2, and the 1/2 is 1/2, so that gives me 3/2. Better way to understand that. Okay, now our two exponents are different, but our bases are the same. So once your bases are the same, you can set our exponents to equal to each other. So even though they look different, they are equal. So we're going to do 2x minus 4 equals 3/2. All right, now we're going to add that 4 to the other side. So adding the 4 to the right-hand side means that we get rid of it on the left. So all I did right here was add 4, add 4. I'm not adding 4 to the 2. I'm adding 4/1 to the entire fraction. All right, and then that 4/1, let's go ahead and rewrite that as a equivalent fraction. So that would be 8/2. I want a common denominator so that I can add these together. So 2x equals 3 plus 8 is 11/2. So 2x equals 11/2. Then you're going to go ahead and divide divide by 2 on each side. And 11/2 divided by 2 is going to be 11/4. Just want to check my answers there. This is number 12. Good, 11/4. Yeah. Remember, dividing by 2 is the same as multiplying by 1/2. So if you want to show that as multiplying by 1/2, and that makes more sense, then you can do that. If I multiply by 1/2 on this side, oh, yay. Okay. 1/2. And then multiply by 1/2 on this side. Let's go ahead and move this. Well, 2 times 1/2 is 1, so you get 1x on the left, which is just x. And 11 times 1 is 11, 2 times 2 is 4, so your answer is x equals 11/4. All right, let's go ahead and go to the next one. Let's go back and see which problem. All right, so our next problem is 16. So 16 is, find the problem, log base 27 √3. All right, so So if you did 27 to the x power, that's correct. And then that's going to give you the square root of, equals the square root of 3. And then I'm going to go ahead and change the square root of 3 to 3 to the 1/2. So I think that's one of the mistakes that was made. This is not your exponent, so don't change it to the power of 3. This should be 3 to the 1/2. Oh, but you can change, yes, you are supposed to change this 27 to 3 to the 3rd power as well. Right, so you did all that correct. Now we're going to use our power to a power rule. So 3 to the 3rd to the x is really 3 to the 3x, because you multiply those exponents together, equals 3 to the 1/2. Once you get the bases that are the same, so this 3, my base, and this 3, my base, are the same, then you can set the exponents equal to each other. So 3x equals 1/2, and then you're going to divide by 3, which is the same as multiplying by 1/3. I'm going to multiply by 1/3 on each side. The 3 is reduced because 3 over 3 gives you 1, so you get 1x. Go up here. 1x is equal to 1/2 times 1/3, which is 1/6. Okay. And the next problem is 24. Okay. So remembering the natural log is base e. Actually, I can just go ahead and write that up here. Base e. This means we're going to write our base, which is e, to what power gives me 1 over the cube root of e squared. So let's go ahead and change our radical to an exponent, because we know that we don't leave them in radical form. So this would be e to the 2/3, because my exponent over my index would be 2 over 3. And then I'm also going to move my base across the fraction line. And when you move the base across the fraction line, your exponent becomes negative 2/3 instead of positive 2/3. And then in that case, x is negative 2 over 3. And then, let's see, 32 is our next one. Okay, so neither of the bases are written down on this one, so these are both base 10. So when we have the same base on each side, log base 10 of something and log base 10 of something, then those two somethings are equal to each other. So these are equal. So we have x to the 5/3 equals 32. Now I'm going to rewrite the 32 as the smallest base I can. I think something that you need to make sure is that both of these are base 10. Sorry, just backing up a second, because some people were thinking that this was base X. This is not base X. This is, X is not written real small and below. So this was a log base 10. And this whole section has common bases. So we didn't have any bases that were different from each other. So if you had a 10 over here, you didn't have an X over here. So that's one thing to recognize, is the X is part of the answer, not part of the base. Then when you solve each of these, it might be a little bit more simple if you recognize that. So I'm going to rewrite my 32 as 2 to the 5th power. And then solving for X, we're going to get X by itself. So you're going to multiply, or you're going to raise it to a new power so that this power becomes 1. So I'm going to raise it to the 3/5 because that would give me X to the 15 over 15 on this side, which is just X to the 1st, or X. And then on the right hand side, I'm also going to raise that to the same power, because if you do it to the left, you have to do it to the right. And that gives me, let's see, 5 over 1 times 3 over 5 gives me 15 over 5, which reduces to 2 to the 3rd power. So X equals 8, because 2 times 2 times 2 is 8.